Hello, let's look at how we can use AI to help us write some code and run it. So we're going to prompt AI for code. We'll save it to a file. We'll execute it. We'll also look at why we need to use as stir and why we need to use as bytes. So with all that being said, let's get going. So the first thing we want to do is look at my article, which I've already written on red and green, working with as stir as bytes, writing data to a file. So we want to write some code to do a task. And what we'll do is we'll ask it to come up with some Python code purely because it helps us see the difference. If we were asking it to write us some Rust code, it could get a little bit confusing with the code that it was creating versus the code that we were writing. So purely from a I can't even say it, didactic point of view, I'm going to ask it to write some Python code, but the program that does all this is going to be written in Rust. So we're going to be using request to make the request to OpenAI. We're going to be using JSON because we're going to be posting some JSON to the OpenAI endpoint. And we're going to be using env for the API key, and we're going to use fs file because we want to create a file because that'll be the python.py file that we put the response from the LLM into, and then we'll obviously write it to a file. So just this is just an overview of the actual code we'll be doing. We'll be set the API key, create a client. So the client is actually a request client. Don't confuse that with OpenAI's API or OpenAI's client. Our response will be the response from sending and awaiting the post of the header, which contains the bearer, the API key, the content type, and some JSON. So we'll be specifying the model, the role, user, content, which is going to be the prompt. So this here is specific to OpenAI, but if you're following it, you'll notice that more and more of the syntax language is kind of converging. So, for instance, Llama models will be using something very similar to this. I recently changed a OpenAI piece of code to use Llama, and I only had to change three. I only had to change 3 lines, and it works straight after. What we'll do then is we'll take the response. So response.json.await. So when we add request, sorry, I said request, that's from Python. When we add request, we need to add the JSON feature. And with that response, we then await it, and then we pass out the first choice, the message, the content. Then we use as stir. Because when we use JSON, the Serde JSON, it returns a value which could be a string slice, etc. So here, as it says in my article, as stir converts the value into a string slice, which is what we need to manipulate the text and write it to a file. Serde JSON value is not directly a string. It's a value that can hold types like string, number, etc. Where it says number, it means i32. So once we've done that, we actually have to write to a file. So that's when we need to use as bytes, because when we use write, all, the trait expects a byte slice ampersand U8, not a string slice. So if you're still learning Rust, this is, I wouldn't say confusing, but you do need to kind of get your head around it. And hopefully this video will assist you with making you aware of the fact that you need to do this. I can't help you memorize it, but it's just practice, I guess. That's how I anticipate it being going forward. I think once you've worked with files, you know that it's a U8. You're working with bytes, so just remember if you're new to Rust, then it's the ampersand because it's effectively it's a it's a borrow. A slice is it's a slice, so it's a view into some existing data. What happens without as bytes? So if you didn't use as bytes, you get a compiler error. So that's enough theory. I don't normally do too much theory because it's not my strong point because I'm still, as the channel name, learning Rust. So if you're still keen to see the rest of this video, you want to see it actually work. So that was the theory, that was the code. Well, I won't do it laboriously. It was just, I'll paste in most of it. Prompt code. I have tested this already, so hang in there. It's not going to be me hacking away. And hopefully that's big enough for you to see okay. So the article's got the code, but it hasn't got all the cargo stuff. So let's get rid of that. Bring up the article. So we need to add requests. Sorry, I call it requests. It's from my Python days. Cargo add reqwest, and then we need to do features JSON. I quite often forget to do this. Then use Surday JSON, so cargo add Surday JSON, and those are stood, so that we get those from the standard library. Right, so we're good to go. So now we can just paste in those three. No point in me typing it all from scratch because it's boring. Right. Then we need Tokyo, so we need to add Tokyo. If you've used Tokyo for async stuff already, then you'll probably be in a habit of doing this. So you do features, and then I just do RT multi thread with the hyphens in between. And then I also need macros. Good. Right. Then we can do Tokyo main. Let's actually let's just build that as well. Just check it's all good so far. Right. So we need to set up a result because we can use the because we're doing a wait, then we can use a question mark, and it's just a lot nicer. So result box down standard error. Once that's done, and then we'll set up the API key. We'll set up the client. We'll create a prompt. So this prompt here is not great. I'll show you why in a second. If you use that, your response will contain a paragraph of text from the large language model, and then it will contain the code. Now, if you change a prompt, you can tell it something like, just return the code, no small talk. It actually understands, when you say no small talk, it actually understands that, and it will return just the code. So that's really worth remembering. And that one error. Yeah, because we've got fn main. It's async main, right? Control Z, cargo B. There we go. So if you're not familiar with Vim, that was Control Z, which just suspends the job. Right. So I'll set the result up then. Result box stood dine. Dine is because it doesn't actually know what the error size could be. Oh, we left out the little greater than sign. Good. And now it's complaining because it's not actually doing anything. Expected result. So that's just to get it to compile, we could do that. Now it's happy. Then we need to do the API key. Oh no, what was it first? The API key, yeah. And then it's the environment variable, which I've already got set, and I'm not going to cover that here, but yeah, that's a whole nother topic, getting your environment variable from your system. You can either create a .env file, you can add it to your bash rc file, your zshrc file. You could actually put it in your code if you weren't sharing it with anyone. It's pretty bad practice, so I wouldn't do that. Okay, let client equal client new. And then we've got the key, the client. Next is the prompts. Yep. Let prompt equal. I might have to come back to this, but let's just for now create me a Python script that fetches the BTC price. I'm doing this because it's going to be live data from Gemini. Using requests. Module. Please do not return any comment before the code or after the code. No small talk. Okay, so we got the key, the client, the prompt. Next, we actually set up what we're going to send. So let response equal client dot, and we got the choice there, so we want to post. Yeah, and if you're sitting comfortably, then we'll begin. So the first thing we want to do is post to this endpoint. And if you're using ChatGPT, it'll always be this endpoint, or will be whilst they're using version 1. I'll just turn off type hints just to make it a bit more easy to see. So that's what we're posting. Then we've got the header. We have to format with bearer space API key, and format is organizing the text for us. Header. So we've got authorization, we've got the content type, application JSON, and then this is the JSON we're sending. You could actually copy and paste all this. The API key you'll need to set up, obviously. So let's put in the JSON. The reason the JSON works is because we've added the JSON features with request. And then send and await. Okay. Next. So we want to get the response. So response underscore JSON, and that's a value, which is why we need to use as stir in a minute. Then once we've got the response JSON, then from that response, we need to pass out the choices, first thing, the message, the content, and then as stir, and then unwrap. If we get the error, then we'll just print no response from API from AI. And then finally, we need to do let note file equal file file create. I think we need to use create script.py. Then we need file.writeAll. Script as bytes, isn't it? That's the content. As bytes. Do we need the question mark? We do, but we don't need the await. Is that right? Yeah. Oh, and then we'll just do a print message. Cheers. Right. There we are. Right, let's run it. So this isn't the delay because of the AI. This is the delay because I compiled it because we're doing it with Rust, obviously. And we've got a 400 byte file here called script.py. Oh dear. Well, it certainly didn't stick to what we told it. So I'm going to pause this here. I'm just going to go and look up my notes and see how I actually successfully got it to run. Back in a sec. Right, let's alter our code slightly with a prompt that I know does work. So goodbye to that prompt. And instead, generate a Python script that fetches the Bitcoin price from Gemini API. Just give the code so it can be run, no small talk. No comments like, here's a simple Python script that imports request libraries to send HTTP, blah, blah, blah. So no backticks either, just code. Run it again. Python script created. Let's look at the script. Hooray, we've got it. Right. That percentage there, I think that's just my terminal. Let's actually open up the script. Yeah. So what we did there was we wrote some Rust code that talked to large language model to ask it to write us some Python code. Um, let's actually run that code. And it's done it, and it's gone off and got the BTC price. So that is a look at how to get the large language model to write you some code. If you want to run the code, I've got it here. I've actually gone in and added a couple of bits. I've added a bit at the end to actually run the code. Okay, so I've added the code bit at the end as well here, so this will be interesting. This is actually the bit that runs the command from Rust. Um, so we set up a Python command. If command new, Python output is okay. So use Python if that works, otherwise use Python 3. Specified script path. That canonicalize. Forgotten what that does. Get the absolute path. Run the Python script, handle errors. So for those that are still watching, thanks for carrying on watching. Let's just dump all this in because this is just straight from ChatGPT. I know it works, I've tested it. I just wanted to show you how to actually do everything in one fell swoop. So what we're actually going to be doing is we're going to be fetching the code and running it. So this is potentially dangerous on your machine. So I would suggest running it in Docker, which is another story and something else beyond the scope of this video. And why is it not liking that? That's fine. I think it was catching up with itself. So canonicalize. Get the path, run the scripts, handle errors, show the output. Right. Cargo build. What I'll do is oh yeah, it needs to use stood path and stood process command. Ah, use stood process command. Right, build it. Once you built it, I'll run it and you'll see how it kind of how quick or how slow it actually is. So um, oh, look at that. So it's non-deterministic. It's not doing the same thing every time. So if we go to the script, it's actually ignored. Do you see this line here? It ignored that. That's really bad. So let's go back to, we told it no comments, like here's a simple Python script. Okay, let's run it again. And it's run, so it's worked. So do you see, I didn't change anything, and yet we got two different results. So this is definitely something to be aware of and to try to eliminate or mitigate against. That's really interesting. So Despite my prompt, it still said, sure, here you go. So it failed. Then it worked. Let's do cargo clean. So it's just removed all of the stuff it's all built for us. We'll have to do a long build again. And once it's done that, we'll run it twice or 2 or 3 times, and we'll just see how reliable it is. Once we've got this working, we can then think about how we could run it safely in a container, or we could also think about how we could modify it to write Rust code and compile it. We're kind of emulating what GitHub Actions does, really. Well, that would be the aim. We're nearly there. And this would, with very tiny modifications, this would work with a local llama model as well. So, okay, let's run it. So cargo run. That's worked. And just so you know it's actually using a new script. You see how, right, we've removed that script. So I'm hoping, or I think that error might have just been an anomaly. Yeah, so it seems to be working fine now. Let's just run it one more time. And you can see it's actually doing something in real time. Let's just look at the script. We'll wrap it up. So import requests, import JSON. I've already got those installed on my laptop. If you didn't already have those, you would just need to ask OpenAI to write you a requirements.txt file, and you'd need to read from that as well. But that's specific to Python. The overall idea behind this video is just writing some code, any code, whether it's Rust, Python, whatever, it doesn't matter too much. What we're doing is we're writing some code and executing it. Good. So thank you for watching. If you've got any ideas, if you don't like it, if you do like it, comment, suggestions, thumbs up, subscribe, and all the usual things that all the YouTube people say. So thanks for watching. Be back soon.